In this video, I want to take a look at dividing algebraic fractions. Now, for dividing algebraic fractions, this just works in the same way as dividing regular fractions. So hopefully by the end of this video, you'll find dividing algebraic fractions nice and easy. So 3 questions, let's just jump straight away into this first one here. Now, all I want to do is simplify fully this division. So just like we would for regular, dividing regular fractions here, I use the method of KCF. Remember, KCF just tells us the way we divide fractions. So the K here tells that we keep the first fraction exactly as it is, don't change it. So if we do that, we get x plus 2 over 3. The C here tells us that we change the division to be a multiplication, like so. And then the F here tells us that we flip the last fraction. So rather than 5x plus 10 over 9, it becomes 9 over 5x plus 10. That's 9 over 5x plus 10. Okay. Now, normally when we're multiplying algebraic fractions like this, or just multiplying fractions in general, what we'd do here is we'd multiply the numerators together, and then we'd repeat that with the denominators. But what I'm going to do here first is I'm going to factorize where possible. And if we look at this, the only place where I can actually factorize here is this 5x plus 10. Okay. Because I can write this now as 5 lots of x plus 2. Okay, so we can factor out the 5. So if we just do that underneath, the left-hand fraction stays as it is. And the numerator here stays as it is, so that's going to be 9. And then this is going to be 5 lots of x plus 2. Okay. So we're pretty much there now. All I need to do here now is just think about where I can cancel. So normally when we multiply again, like we just said, we multiply the numerators together, do the same with the denominators. And before we do that, I'm just going to cancel where possible. So I've got an x plus 2 here, I've got an x plus 2 here. So they'll cancel when we multiply across. I've got a 9 here in the numerator, 3 here in the denominator. So in that case, we can divide both of those by 3. That'll leave me with 1 here in this denominator and 3 here in that numerator. And I've got a 1 here. We've got rid of that x plus 2, so that just becomes a 1. And at this point now, we can multiply across. So what I've got here is 1 times 3. That's just going to give me 3 here for the numerator. And then in my denominator, I've got 1 times 5. Okay, remember the x plus 2 cancelled. So 1 times 5 gives me 5. Okay. And in that case, we get 3/5 there. Okay, so if we simplify that fully, we get 3/5, giving us the solution to the first question. Now moving on to the next one here. Again, I just want to simplify fully. Now this one looks a lot more involved, and that is true to be fair, because we've got quadratics here now. There's going to be a bit more work to this. So again, we just start now by using KCF. So we keep the first fraction. We keep x minus 2 over 3x plus 9. We change the division to be a times. So we change that to be a times. And then this last fraction here, we flip that. So we're going to get 3x squared plus 10x plus 3 as my numerator. My denominator now will be x squared plus 2x minus 8 there. Okay. And again, what I need to do now is factorize where possible. I can't do anything with x minus 2, but this 3x plus 9, we can factor a 3 out there. So we do this underneath, I get x minus 2. That's going to be over 3 lots of x plus 3. And we times this. So factorizing this numerator here first. So I'm going to have a 3x at the front of one of these brackets. I'm going to have an x at the front of the other bracket. What would this be? That's going to be plus 3 there and plus 1 there. Okay, that would give me 3x squared plus 10x plus 3. Good, that's fine. Factorize the denominator here, a bit easier. 2 numbers that times give me minus 8, but add to give me 2 there. Have an x at the front of both of these brackets again. So what's that going to be? Positive 4 and minus 2 there. Okay. So again, all we're doing here now is just cancel where possible. So I've got an x minus 2 here. I've got an x minus 2 here, so they'll cancel. I'll just leave the other one here in this numerator. I've got an x plus 3 here, an x plus 3 here, so they'll cancel. At that point there, we can't cancel any further. I've got 3x plus 1, but no other 3x plus 1s, and an x plus 4 there, but no other x plus 4s. So if we express this now as a single fraction, I'm going to get 1 times 3x plus 1, so that's just going to give me 3x plus 1. And then in my denominator here, we're going to get 3 lots of x plus 4 there. Okay. I'm not going to bother expanding that based on the fact that we're just leaving it in its simplest form. But that would give us our solution there. So we've got 3 times x plus 4, giving us 3 lots of x plus 4 for the denominator. And that gives us the solution to the second question. Now, before we start this last one here, let's just clear the screen because the last one is pretty tricky, to be honest. So again, we're just dividing here, and we need to show that we get 3 minus x. So where do we begin? Well, again, let's just use KCF. So we keep the first fraction as it is, change the division to be a times, and we flip this last fraction here. I'm going to get x squared minus 9 over 2x plus 5. Change the division to be a times, and then we flip this last fraction here. So I'm going to get 2x plus 5 times 3 minus 2x. And that's going to be over 2x squared plus 3x minus 9. Okay. Now here, again, just like we've done with the previous two questions, we're just going to factorize here where possible. Well, x squared minus 9 here, hopefully you notice that's the difference of 2 squares. So, do that over here. I can write that as x minus 3 times x plus 3. Okay, so that's x squared minus 9. The 2x plus 5, we can't do anything with that, so we'll leave that as it is. Now we times, obviously this is already factorized, so we'll just keep that as it is. So 2x plus 5 times 3 minus 2x. And in my denominator here, we need to factorize 2x squared plus 3x minus 9. So I'm going to have a 2x at the front of one of these brackets and an x at the front of the other. I just need to think about what I need here. Minus 9, but I had to give me 3. So one of these is going to be positive 3. I think this should be right. So positive 3 and minus 3. Let's just double check this. I get 2x squared. I get 6x there. Minus 3x gives me the positive 3x, and then minus 3 times 3, minus 9. Perfect. So everything here up to now is good. Everything's correct. All I need to do now is just cancel where possible. So I've got an x plus 3 here, an x plus 3 here. We'll cancel those. I then got an x minus 3 here, no over x minus 3, so we'll leave that as it is. I've got 2x plus 5 here and a 2x plus 5 here, so we can cancel those. And at that point, this looks okay. So we're happy with that. So what we do now is we multiply across just like we did with the previous two questions. So I'm going to get x minus 3 times 3 minus 2x. So x minus 3 times 3 minus 2x. So that's my numerator. This here is just a 1. We cancelled this term here, so that's a 1 underneath. So 1 times 2x minus 3, which would give me 2x minus 3 there. Now at this point here, we're pretty much done, but notice that our solution is nowhere near what we've got here. Okay, they've just got 3 minus x, and we don't have a single 3 minus x here. So how do we make this final connection now from here to our solution? Well, notice that I've got an x minus 3 here, and the solution is 3 minus x. So we're not actually that far off. It looks like we are, but we're not actually too far off. What I need to do here is a bit of a clever trick, and I need to think about how I can now cancel this denominator here and this 3 minus 2x. And the way I can do that is to take a factor of minus 1 out of this 3 minus 2x. Okay, if I take that minus 1 out here, so what I'm going to get then, if we do it over here, is minus x minus 3. So I've just took a factor of minus 1 out here. The 3 minus 2x then changes signs. Okay, so we took that factor of minus 1 out, so now the signs will change. So rather than it being 3 minus 2x, it's going to become 2x minus 3. We get 2x minus 3. I appreciate we're running out of room a little bit here, but hopefully you can still see. And then finally, in my denominator, we've still got the 2x minus 3. So we've got 2x minus 3. And notice now, I've got a 2x minus 3 in the numerator, a 2x minus 3 in the denominator, and they cancel. And what I get left with there then we finish all the way up here, so I just get left with minus x minus 3. Well, expand this now with this minus 1 on the outside, and what you're going to get here is minus x plus 3, which notice is exactly what they wanted to show here. So therefore, this is equal to 3 minus x as required there. Okay, and there we have it. So that's our solution. But like I said, the last part is pretty tricky. It's hard to spot how to cancel that last kind of term here. And it's something that comes with time and practice. But hopefully, the other two questions didn't seem too bad. So that brings us to the end of this video on dividing algebraic fractions. In the next video, we're going to take a look at exam revision for algebraic fractions.